Alright guys, welcome back. We're going to look at what we are going to call probability of dependent events. So we've already talked about probability of independent events, where one event does not directly affect the other. So you've probably guessed it that dependent is going to have an effect. So let's look at that. What happens when, I forgot to write that word, when the first event does affect. So when the first event affects the possible results of the second event. So this includes drawing an object and not replacing it. And if you stop and think about it, if I have these three markers and I take this purple, I have a 1 out of 3 chance of getting that purple. If I replace it, I still have 3 total. If I don't replace it, now that's directly affect drawing a second pen, because now I only have 2 total. So when you're not replacing an event, the pen, the marker, whatever it is, it's directly affecting your second part or your second event because your total is changing. It also including drawing objects at the same time. Okay, so let's look at a couple of examples. In these little boxes here, these are your steps to take. So first, draw a model to help yourself out. Draw yourself a picture. Then we're going to write a ratio for the first event. We're going to remove the results from that model because it's no longer there from that picture. We're going to write a ratio for the next event, and then just like what we've been doing is we're going to multiply the fractions. So again, these steps will make a little bit more sense once we look at some examples together. So let's go ahead and do that. So it says a marble is randomly picked from a bag containing marbles of 4 different colors. The color of the marble is recorded and not returned to the bag, so you keep it. So anytime they say you don't replace it, you keep it, automatically is going to go to dependent event. Then we have a second marble that is picked. What is the probability of choosing white and then blue? So we're choosing white and then we're choosing blue. Okay, so my first event is choosing the white marble. So if you label these, it's really going to help you out. And the second one is choosing the blue marble. Choose blue. Okay, so over here we have our table. So if it helps you out, we have 6 white. So 1, 2, 3, 4, 5, 6. 2 green. Should have gotten all these colors for it differently. We have 1 red. I'm just going to keep that as this one because we're looking for white and blue, so I'll use the colors to go with that. And then 3 blue. Guess I could have used the blue marker with that one, but that's okay. We're just labeling it. So if we have 6 white, 2 green, 1 red, and 3 blue, 6, 7, 8, 9, 10, 11, 12. We know we have a total of 12. And that makes sense because look at your picture. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the probability right now of you choosing a white marble is 1 out of 12. Let me keep that with that color. 1 out of 12. Well, if you take that white marble and you keep it, now let's look and see what happens. Well, how many are blue? We still have 3 blue. But are there 12 total if you kept this one? Nope, there's 1 less. So what happens when it's dependent event is your total is going to change. Sometimes your part change, but it's only if it's the same color. And we'll see that in just a minute, if possible. Because me taking the white marble out only affected how many white marbles were left, but it also affected the total. So I still see 3 blue, but now I don't have 12 marbles because I kept that other one. So again, we're going to multiply across. So 1 times 3 is 3, and 12 times 11 is 132. Again, this total changes because we don't put that first marble back. So this is something that you've got to be really careful about and read carefully, because if you accidentally put 12 there, I bet 3 over 144 would be a trick answer, because 12 times 12 is 144. Okay, so this is why we're always telling you to take your time, reread, double check your work. All right, let's look at two more and then get you some independent practice. What is the probability of reaching in, picking out the letter R, and then picking a vowel? So here are letters that spell the word orange. So our first event we want is picking the letter R. So I'm going to label that under my fraction, pick the R. And then the second one is pick a vowel. Well, we need to remember our vowels are A, E, I, O, U. And if they tell you why, we'll count it, but we're just going to count it as A, E, I, O, U. All right, so let's pick an R. So we see that there's one R out of 1, 2, 3, 4, 5, 6. Okay? If you reach in and keep that letter R, so that letter R is now gone, you've kept it. Now we're picking a vowel, A, E, I, O, U. So there's 3 letters, but if I kept that R is no longer in there. I don't have 6 tiles left. I now have 5. Okay? So now we multiply across. 1 times 3 is 3. 6 times 5 is 30. So we could say 3 out of 30, or you can even reduce this to 1 out of 10. Now something to be mindful and careful of, even though this one did not directly say we were keeping the R, if it doesn't say you put it back, then that's assuming that we kept it. So that's something to be really careful about. If this problem said, what is the probability of picking an R, replacing it, and then picking a vowel, then my total would have stayed the same at 6. So we just need to be kind of careful about that and double check with your teacher for clarification as needed. Okay? If it is going to be an independent event like in our previous lessons, they'll be more specific about replacing it and putting that back, okay? So just something to think about. All right, last one together. To choose the captains for a math team competition, Miss Tovar randomly drew the names of 2 students. If there were 8 girls and 4 boys in the drawing, what is the probability that she drew a boy's name and then a girl's name? So boy's name first, and then my second ratio or probability, either way we want to say it, is the girl's name. What are the chances? Okay? So again, draw yourself a model so you can really help see what's happening. If there are 8, how many boys? There's 4 boys. So 1, 2, 3, 4. Just write the letter B for boys. And there's 8 girls. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Then we're going to say the boy's name. Okay, well there's 1, 2, 3, 4 boys' names out of, well, 8 plus 4 is 12. And you can see 12 letters there. 3, 6, 9, 12. Okay? Well, if she's picked the first team name, is she going to put that team member's name back? No, she's already got that math team competition. So that first boy's name is done. That's the first team captain. But we still have 8 girls, but because that first team captain is already named, we only see 11 people's names that would be left over. We're not replacing that first name because that first name drawn will be the first math team captain. Okay, so if you stop and think about it, that makes sense. So we have our first event multiplied by the second event, and then we'll get our answer. So 4 times 8 is 32. 12 times 11 is 132. So there's a 32 out of 132 chance for her to pick a boy's name with that specific girl's name. So we didn't list any names, but that's what we're looking at, okay? So if you have any questions at any time, of course, let us know. We're happy to help you guys. But if you stop and label these each time and double check your work, you'll be good to go, okay? Always, always, always let us know what we can do to help you. Good luck.